Good morning and happy Friday. Today we are going to get into force in physics. We've examined movement of objects in both uniform motion and non-uniform motion. And we will see that those concepts are going to build up as we continue learning in physics. So with force, what we should probably do first is look at a definition. So the definition of force is either a push or a pull on an object. This kind of push or pull is measured in a unit called newtons, which gets the letter N. Now, why is it measured in newtons? Because Newton is the one that came up with the laws of motion. So when we look at Newton's first law of motion, we see that what he said was an object at rest will remain at rest unless acted upon by a force. And we're going to talk about the force has to be unbalanced. We're going to just look at that in about a second. And then the second part to this is an object in motion will remain in motion again unless acted upon by a force. And we see that, right? Let's say that I were to push a chair across the room. The chair eventually stops because of things like friction with the floor, gravity that is pulling the chair down, the heat that is created when the wheels are spinning, the noise that the wheels make as the chair is going across the floor. All those are forces that are going to eliminate the initial force that I put into the chair's movement with my arm. And so that particular chair that is in motion is going to be acted upon by other forces that are going to slow it down. So they're going to prevent its motion from continuing. If it was done in a vacuum without any opposing forces, then the movement would be continuous. They talk about that in space, right? Where the movement would have been continuous. Right, so let's take a look at what it means by balanced versus unbalanced force. So when we talk about a balanced force, these guys are going to be equal in magnitude. So both are pushing or pulling in the same amount, but in opposite direction. And therefore they cancel each other out. All right, so if we think of this is one force, this is the other force, they are the same amount and they are in opposite directions. Or if I had this force and this force, again, they are the same amount, opposite direction, and therefore they cancel each other out. So those are going to be balanced forces. Unbalanced forces can happen two ways. Either one force is greater than the other, or they're not in the opposite direction. So here is the example of one force being greater than the other. Okay, and so those are going to be unbalanced. So here I'll give you the example of, a car moving down the highway and a mosquito moving the other way. Okay, and so what's cool about that is at this very point, the force exerted by the car and the force exerted by the mosquito is exactly the same. But because the car was coming with a greater acceleration and it had a greater force in this direction, then obviously once that point is passed, the car continues moving and takes the mosquito with it on the windshield, right? Or you could have, they are balanced, not balanced, they are the same magnitude, but they're moving in the same direction. And so that's an unbalanced force. Okay, so necessarily doesn't have to be that they're different magnitude, as long as they're going in this in the same, oh sorry, I should say opposite here, not opposite direction. Okay, now so that's what Newton said. It has to be an unbalanced force. It has to be this, and that's how you're going to get the object either changing the fact that it wasn't in motion or remaining in motion, okay? Or not remaining in motion, it being stopped. So the force needed to change the motion of an object depends on two things. So there are two factors. One is the mass in kilograms of the object. Okay, so obviously the heavier the object will require more force. So the mass is one. And then the second thing that is going to determine how much force I have to apply to an object is the acceleration. And we just learned about acceleration. It's meters per second squared. That's the unit for it. So how fast do I need, how much do I need to accelerate the object? The faster the rate of change, the higher the force needed. So the faster the acceleration or the rate of change, the more force needed. Okay. As a formula then, we see these two factors. So force, F, is going to be a product of the mass and the acceleration of the object. So this is the formula we need to find force, where F, this is the force in newtons, M is the mass in kilograms, and A is the acceleration in meters per second squared. And in fact, a newton is a kilogram per meter per second squared. Okay, so a newton right here is a kilogram per meter per second squared. Okay, but instead of writing that out, what we write out is a newton. Now, as an aside, what I want you to know is that your weight is not the same thing as your mass, okay? The mass is the amount of matter that makes up the object in physics, whereas weight is a force, okay? So mass, this is the amount of matter in kilograms, obviously. So what weight is, this is a force being applied by gravity on the mass. Right. So for that, we're going to look at a simple calculation, and it might surprise you to know. So let's have a look. What is your weight? Let's try an example. Let's do that calculation. So if we start off with your weight, all right, if you were to jump on the scale right now, we would need your weight in kilograms. So in order to do that, you would take your weight in pounds and divide by 2.2. Because 1 kilogram is 2.2 pounds. So I'm going to give you an example. So let's say that you are 130 pounds. So 130 pounds. And we were to divide by 2.2, we would end up with 59.1 kilograms. Okay, so that is your weight in kilograms. Okay, but now we have to find out force, mass times acceleration, or this is the same thing as saying your weight is your mass times the acceleration. But why do I use this g? Because g is a constant and it is the acceleration due to gravity. Any object on Earth is going to have the same acceleration due to gravity. When you go onto a different planet or on the moon, or when you're in space, your acceleration due to gravity is going to be different. But on Earth, it is 9.81 meters per second squared. That's how much we are accelerating towards the middle of our planet, right? So given that, then, I have to find mass. I have my weight, so my weight is 59.1 kilograms. Mass is what I'm looking for, and 9.81 meters per second squared is the acceleration due to gravity. So I take the mass, and I go 59.1 divided by 9.81, and I get 6.0 kilograms. So your mass, the amount of matter that makes up your body if you're 130 pounds, is 6 kilograms. And this might not mean a lot to you in kilograms yet. So I'm going to convert it back to pounds, and this is 13 pounds. So if we were to take your body and sort of squish it all together, it would be less than a 15-pound weight. Okay, you know, the weights that you use at the gym. Less than a kettlebell or whatever. So that's how much mass you have in your body. It is the acceleration due to gravity pushing you against the scale on the floor of your bathroom that gives you that number of 130 pounds. Okay? So now when it comes to force, we're going to see it in terms of accelerating objects. And if a force is applied in the same direction as an object, then the object will accelerate. It will change its speed over time. If the force is applied in the opposite direction, it'll still change the object's speed over time, but it will decrease it. So it would either, what we in English we would say accelerate or decelerate. So increase the movement or decrease the movement. All right, let's try a couple of questions. A 1,000 kilogram car is accelerated at 2.5 meters per second squared. How much force is acting on it? So this is an easy, straightforward plug and play sort of question because we're looking for the force. We don't even have to manipulate our variables. We don't have to manipulate our formula. So we have 1,000 kilograms, 2.5 meters per second squared, and we're going to get 2,500 Newton. Now, the problem is here that our question has 2 significant digits, and we are ending up with 4. So there are 2 ways that we can do this. We could have our answer be in kilonewtons. That's a possibility. So we divide by 1,000 and we get 2.5 kilonewtons. Or we could do it in scientific notation, and we can have 2.5 times 10 to the 3 newtons. Okay, so both of these are correct as answers. Question 2. So here I'm going to put example 1, example 2. And I'd like you to try this. So pause the video, try it, and see if you can get the same answer. Okay? So we're going to have, what is the mass of a crate that weighs 450 newtons? So here again, I'm going to list my variables. And I can write it as G or A, it doesn't matter. So I have the force. I also have the acceleration due to gravity because I am given a weight. And weight, we said, is a product of your mass and the acceleration due to gravity. So we're given that number. So again, what we're doing is the same thing we did with our example right up here. We're finding the mass, which is the force divided by the acceleration due to gravity, in this case. And to 3 significant digits, our answer is 45.9. Okay. And then the next one I want to do is I want to try something a little bit more complex and see if we can get there. So example 3. Example 3 says, what force is needed to accelerate a 500 kilogram cart from rest to 20.0 meters per second in 5.0 seconds? Okay, so here I'm going to give you a hint. Anytime that you see a question like this and you're kind of going, okay, what force is needed to accelerate? I have mass, I'm given some sort of a speed and time. Write things down. Write things down, write some variables down, because that might give you an idea of what formulas to use. So I'm looking for force. I have mass. And I need the acceleration. So force is mass times acceleration. I have this one and this one, and I need that one. Okay, so then what else do I have? I said the cart is accelerated from rest, so my initial speed is 0 meters per second, and my final is 20.0 meters per second, and I have a time of 5.0 seconds. So I'm looking for acceleration. The formula for acceleration that we learned in the last section was VF minus VI divided by delta T. Oh, now I see that I have all the variables that I need. So 20.0 meters per second minus 0 meters per second in 5 seconds. I have an acceleration of 4.0 meters per second squared. Now this number can be applied to that formula. So I have 500 kilograms, 4.0 meters per second squared, and I end up with 2,000 newtons, or in this case I need my answer again in 2 significant digits, 2.0 kilonewtons, or 2.0 times 10 to the 3 newtons. Those are both correct. Okay, so you see how what we learned in the previous unit can be used for, in the previous section can be used for this. All right, so then next what I'm going to do is I'm going to post this and then give you a worksheet to practice some questions, and then I'll leave you with that for the weekend, and then we'll see each other again on Monday. Have a good weekend.